It is, as Noreen said, a 50th anniversary for Ideas. In fact, a little later this month, we will be celebrating that anniversary 4 times on radio and broadcast, and once, if you happen to be in Toronto later this month, we'll be doing a special event in the Glenn Gould studio to celebrate that 50th anniversary. I consider this, in some sense, the beginning of the celebrations of this month, because in some real sense, I honestly believe that the subject matter of our show is not only the core curriculum of contemporary culture, but it is indeed the dialogue between democracy and knowledge. Obviously, a program called Ideas is very much about knowledge and has been talking about those kinds of knowledge issues for about 50 years. I think also if you looked at the archive of what we produced over 50 years, 5 nights a week, we have dealt fairly frequently with the topic of knowledge and democracy. And tonight, although I'm forbidden contractually to mention a word that starts with an E and then has E-L-E-C-T-I-O-N. Obviously, the topic is extremely important right now, and the dialogue between knowledge and democracy is something that every Canadian should take very much to heart and actually act accordingly on a date later this month between the 18th and the 20th of October. I think it's something that means not only what the results of this election will bring, but also the future of our country. And so it seemed extremely valuable and important for me to accept the invitation to be here for these 3 days, to engage in what I think will be fascinating, stimulating, and important dialogues, conversations about what we are talking about tonight. By way of introducing the speaker tonight, I should say that he's written 18 books, and if I just listed the titles of those books, I would probably take more time than I should just to introduce him. His most recent book is a book which is very relevant to the topic. It is, in fact, called Are We All Scientific Experts Now? And that's a fascinating question. I want to just tell a tiny anecdote, and I only met Professor Collins on the stairway coming up this evening, but I read about him as everyone does on the web, and the anecdote or the story that struck most home to me as the host of a program called Ideas is the story about his own personal, autobiographical, I would say, connection with knowledge. Professor Collins studies a number of things, but he's spent a lot of time, more than a decade, studying the social reaction or the social reality behind the scientific response to something called gravity waves. Now, I don't know how many of you are actually physicists or scientists. I don't know much about gravity waves, but I know that Professor Collins does, and this tells you a little something about what he defines knowledge as, or many of the ways that he characterizes the complexity of knowledge. He actually took a test. And at some point, somebody decided they would send him an email test with 7 questions about gravity waves. And the test was sent not only to Professor Collins, but also to a number of professional physicists who were also given the same questions about gravity waves. And then there was a panel that judged the answers and tried to decide which person gave the answers of somebody who was not necessarily a professional physicist, and which one gave the answer that was those of somebody who had studied mathematically, scientifically, whatever, gravity waves for a number of years. And the person who that committee decided was the physicist was, in fact, Professor Collins. He distinguishes in that context the difference between various kinds of knowledge. He talks about a sort of interactional expertise, and I would, as a host of a program called Ideas, say, yeah, I have that kind of knowledge. A lot of people think I know a lot of things about a lot of things. Noreen seemed to imply that I know almost everything about everything. Well, no, I think I know almost everything about nothing. But I do have a facility, or at least an ability, I'm a quick learner, to pick up on what people are saying, to, in some sense, translate it from what might be academic language into the language that real people might understand. And I think I actually do have a sort of interactional expertise. That's the kind of knowledge I have, and it's a knowledge that I value. But there is another kind of knowledge which Professor Collins identifies. It's different, not necessarily preferable, there's no hierarchy here, but that different kind of knowledge is contributory expertise. It's the kind of knowledge that an actual physicist who's studying gravity waves might be able to give answers to, or a question about gravity waves that was answered by a physicist would involve that kind of contributory expertise. And this evening, I think you'll see, and I'm sure that Professor Collins will prove, that he has exactly that kind of contributory expertise on the topic at hand, and that is the dialogue between democracy and knowledge. Please welcome from the University of Cardiff, where, to give him another title which would give him every right to speak here tonight, he is the Distinguished Research Professor of the Center for Study and Knowledge, Expertise and Science at Cardiff University, Professor Harry Collins. There will, by the way, be a question period at the end of this, but Professor Collins will give you lots of material on which to base your questions. Professor Collins.
Thanks. How I hate introductions like that. How can I possibly live up to that? Okay. You know, that's awful. I shouldn't be here. You're now going to see just what a mistake this Barbara Nice has made. So I'm just a professor who sits around and writes books. I don't know a whole lot about knowledge and democracy, though I'm going to say a bit about it tonight. I'll say a certain amount about interactional expertise. I'm going to actually suggest that Paul maybe doesn't have interactional expertise, so that's going to be interesting anyway. See what he says about that. And I'm just going to tell you about my stuff. And here and there it touches on this question about knowledge and democracy, but you may have to do some work yourself to make it fit properly, because I haven't done the work. Okay. So that's our little centre in Cardiff. It's called the Centre for Study of Knowledge. Centre for Study of Knowledge, Expertise and Science. That's right. That's what it's called. We used to run a centre when I was at the University of Bath. About 30 years ago, we used to run a centre called the Science Studies Centre, which was, myself and my colleagues were among the people who began a trend in science studies, which we now call the second wave of science studies. I'm going to explain that term to you in a moment. But we used to take great pride in that, because the work we did became quite well known internationally. And occasionally, say, people would visit us from other countries, North America, for instance, and they'd come and say, "Where's the Science Studies Centre?" And we'd say, "Well, it's the second drawer down in that filing cabinet." And it's a little bit like that now. There's just a handful of us. It doesn't have any funds, but what we do is try and write stuff that people argue about. So let me tell you about it. Waves of science studies. This schema comes from a paper we wrote in 2002, which caused quite a splash at the time. We didn't expect it to cause a splash. We thought it was just a nice little paper, but turned out that people didn't like it very much. They criticised it heavily. But nevertheless, we've stuck with it, and it's slowly picking up. We say there are three waves of the subject called science studies. What is science studies? It's a combination of sociology, history, philosophy of science. It's people who study science without being scientists. They study it from the outside. The first wave of science studies ran up strongly up to, say, the 1950s, maybe a bit longer than that. And that was the wave in which it seemed obvious to everybody that science was the preeminent way to make knowledge. And the questions were, for philosophers, how does it work? How does theory and experimental results combine? Famous names like Popper and Duhem and Quine and various other people, the philosophers of science, trying to work out the logic of scientific discovery, as Popper called one of his books. And among the sociologists, the famous sociologist was Robert Merton, and the sociologists took their job to be to talk about what kind of society best nurtured the production of scientific knowledge. Robert Merton had a theory of the norms of science. I'm going to come back to that later in the talk. He said that science ran with a set of norms for which he invented an acronym, KUDOS. And he said that these norms were best established, were best nurtured in democracies. Democracies were therefore the best places to produce good science. That was wave one of science studies. And then wave two was a kind of bombshell that happened among a small group of people who studied science from the outside, which began in the 70s or maybe a little bit earlier. An iconic book, you could say, was Thomas Kuhn's Structure of Scientific Revolutions, the best-selling academic book of the 20th century, people say, and no reason to deny it. I know it sold about 1 million, at the very least 1 million. And Thomas Kuhn, I mean, Kuhn's book I think of as a book which was a product of its time, the 1960s. So I was growing up in the 1960s, and things were really different in the 1960s. You know, between the 1950s and the 1960s, a lot changed. And the great thing about being as I was a master's student then in the 1960s, and an undergraduate student in the 1960s, is you could believe pretty well anything, and it was okay. Remember Carlos Castaneda? Remember that? And I always remind people of this. At the time, I think it was the early 70s, a psychologist from the University of California at Davis called Charlie Tart published a paper in Science journal, Science no less, you know, one of the leading, Nature probably just about beats Science, but Science is very much close up there, leading scientific journal in the world. And this paper, I still remember it, it said, look, we should have a special self-contained scientific paradigm for science done by people on LSD. And he meant it, and everybody took it seriously. Oh yeah, of course you're in a different paradigm when you're on LSD, therefore you should do science in a different way. Yeah. And of course there should be, you know, there should be a special science for people on LSD, because only they can understand what each other are talking about, and that's the science. Okay. That's what it was like then. It was great. So, by some luck, I did some work which was well recognized in those days. I'll tell you a little bit about it to give you an idea. First thing I did was ran around. I was looking at how people learned to build a new kind of laser called a transversely excited atmospheric pressure carbon dioxide laser. I wrote my little dissertation as a master's student called The Sociology of the CO2 Laser. See, nobody had ever heard of a title. How can you have a sociology of a CO2 laser? Well, an insane title. But you could do things like that then, you see. And the thing I showed was that you could only learn to build a laser if you spent time with other people who'd built a laser. I mean, not the first person who invented it. Somebody invented it in the first place, but after that you wouldn't be able, you could build your laser from your circuit diagrams and so on, stick it on your bench about this big, but it wouldn't work. And if you wanted a laser that actually worked, you need to spend time with other people who got a laser that worked. And I showed why that was, what the people who hadn't spent time with other laser builders were missing. And then I went along and I decided I should compare this for my PhD with some other areas of science. And I compared it with 3 or 4 other areas of science, but to cut a long story short, with this field of gravitational wave detection, which Paul mentioned. In fact, it's not 10 years that I've been studying it, it's 45 years. Because I started in 1972 and I'm still studying it. Okay, gravitational wave detection, when stars collide, according to Einstein's general theory, it'll make space quake a bit. And if you've got a sensitive enough detector, you should be able to see those quakings because your detector will vibrate a bit. And in 1972, a man called Joseph Weber from the University of Maryland was one of the most famous scientists in the world because he said he had built an apparatus cost about $100,000. It consisted of a ton or so of a cylinder of aluminium alloy weighing a ton or so, and he says he was seeing his cylinder quaking in coincidence with another similar cylinder which was in Chicago. He was at the University of Maryland. They were quaking at the same time, and he was seeing about 7 gravitational waves a day. And other people said, no, that cannot possibly be right. The energetics of that are completely wrong. If you were seeing that much gravitational wave energy, then the whole of the Milky Way would be being burnt up and turned into gravitational waves. Can't be true. Other people started building gravitational wave detectors, saying, look, my gravitational wave detector doesn't see them. Mostly they said that. And so there was this argument, which I studied as a sociologist. How are they going to settle this argument? And one of the things that I eventually realized, it was going to be very, very difficult to settle, because it wasn't like the T laser, the transversely excited atmospheric pressure CO2 laser. With the T laser, if you switched it on, produced a very powerful beam of infrared radiation, and the wall of the laboratory would start to smoke. And if it wasn't working, the wall of the laboratory wouldn't start to smoke. Okay, but if you were building a gravitational wave detector, the argument was, well, should it see gravity waves? Well, yeah, it should see gravity waves if Joe Weber's right, but if Joe Weber's wrong, it shouldn't see gravity waves. So what's the criterion for whether they had a working gravitational wave detector? And after a considerable trauma, I suddenly realized, hey, this is a still more interesting topic. How do scientists decide whether they've got a working apparatus when they're trying to test somebody else's result? So what I pointed out was, actually, these arguments, when they get serious, they change. They change from people saying, no, we can't get the same result as you, to people saying, hey, you don't know how to build the apparatus properly. That's why you're not seeing the same result as me. And it's very difficult to find a criterion for whether you've built the apparatus properly, because experiment is a skill, and a skill is laden with tacit knowledge. And how do you test for whether people have got the tacit knowledge? And so this was my contribution to the start of wave 2 of science studies. I said, well, people actually can't test whether something's true or not by repeating each other's experiments. What they actually do is go around smacking each other around the face until one group gains the consensus, and it's much more like a changing fashion than it is like a logical process. So that was my contribution to wave 2, and I became fairly prominent in wave 2. Now let me just give you a little diagram of what wave 2 said. So before wave 2, in wave 1, we had Mount Science. You know, it's a bit like Mount Rushmore. There's a face of Einstein is carved on it, Newton's carved on it, and so on and so forth. And what wave 2, all these nasty, unpleasant, annoying sociologists did was to erode Mount Science down and make science level with the rest of the cultural plane. There's nothing special about science any longer, nothing logically special about it. Science is just like everything else. And that was me till about the year 2000. And then I thought, well, you know, about the year 2002, we published this paper called The Third Wave of Science Studies, in which we said, now, we've done wave 1, we've done wave 2, time to move on to wave 3, because wave 2, which at that time, by that stage had been absorbed into the whole of postmodernism and all the rest of it, wave 2, it's a little bit worrying. I mean, what used to worry me was my colleagues who were saying, well, every person is equally an expert. There's no, you know, scientists aren't anything special, lay people are equally expert. So you've got, this is another model that we came up with for how different kinds of knowledge works. We call it the locus of legitimate interpretation. And up to that point, you could say that the difference between, say, the sciences and the arts were their different loci of legitimate interpretation. If you were doing a science, the people who had a right to criticize it and decide whether it was good science or not were your immediate peers and fellow producers of scientific knowledge. Whereas if you were producing artistic knowledge, say you're a painter or a playwright or something like that, the people who had the right to say whether it was good stuff or not were the public and their representatives, the critics. So the locus of legitimate interpretation was over to the right for the arts and over to the left for the sciences. And what Wave 2 had made it possible to was to shift the locus of legitimate interpretation for science over to the right. Anybody could now criticise scientists or consider that their opinion about science was as good as anybody else's. And it was this that began to worry me. So if you've got some scientific or technological claim, you've got, on the one hand, the scientists deciding what's what, which is the traditional way. On the other hand, you've got the public deciding what's what. And it seems that if Wave 2 was correct, more and more democratization of science was the only imaginable consequence, with the locus of legitimate interpretation moving to the right. But then you get some terrible things happening. And let's say an example of this is the mumps, measles and rubella revolt, which certainly took place in Britain. Did you have the same here? Yeah. So what you have with the mumps, measles and rubella revolt is ordinary people, parents, saying, my child became autistic after they were injected with MMR. And even though all these huge numbers of epidemiologists and medical scientists and so on say that MMR isn't dangerous, my view is as good as their view. And we're not going to give our children MMR vaccine. We're not going to inject our children. Unfortunately, this was picked up by journalists, decided that these views, the parents versus the epidemiologists, should be balanced, because balance is a journalistic norm, okay? And so you had a parent on the one hand and the whole body of epidemiology on the other, arguing with each other. Parents didn't know which way to jump. They jumped for their own opinion, because it's pretty terrifying if you have your children vaccinated and 2 weeks later the child becomes autistic. What the parents didn't realise is that there's an equal number of children who became autistic first and were vaccinated 2 weeks later, but the only way you see the causal arrow running is from the vaccination to the autism. You don't see a causal arrow running from the autism to the vaccination, because it doesn't make sense, but statistically those things actually balance out. And there was never the slightest evidence, incidentally, that MMR caused autism. There was absolutely no evidence. In spite of people saying there was a paper in the Lancet which demonstrated this, there wasn't. If you read the paper in the Lancet, there is no evidence for MMR vaccine causing autism there. It's just that everybody thought there was, because Andrew Wakefield, who wrote the paper, said there was in a news conference, but there wasn't any evidence. So we thought we had to kind of get rid of this. Now, one way that some people have tried to get out of this is, and I discuss this in that little book that Paul mentioned, is they say that scientists should show they're working in order to help the public make assessments. If you show what you're doing, the public can make assessments of what you're doing. But there's a long quote. We're going to run out of time, so I won't go through it all. But that's completely impossible. What scientists do is far too complicated. And scientists, they can't describe what they're doing when they're reaching a conclusion. There's too much matter of social consensus going on. So that isn't going to work. And then you have this attempt by Thabo Mbeki to shift things around the general public. In this case, his second chamber of his South African Parliament. Thabo Mbeki said to his second chamber, this is Thabo Mbeki when he decided not to distribute antiretroviral drugs to pregnant mothers in South Africa. There exists a large volume of scientific literature alleging that, among other things, the toxicity of this drug is such that it's a danger to health. To understand the matter better, I would urge the honourable members of the National Council to access the huge volume of literature on this matter available on the internet, so that all of us can approach this issue from the same base of information. And there was this controversy going on the internet. If you did look up the internet, you would find an argument about whether antiretroviral drugs were efficacious and safe, but in fact, you can't tell what's going on from the internet. Point of fact, that argument had been long over within the scientific community, and the only place that the people who are arguing for the non-efficaciousness and danger of antiretroviral drugs, the only place they could publish was on the internet and other fringe scientific journals. So it just, it's dangerous to democratize science. Incidentally, here's something that we discovered just the other day, that the Republicans in the US are now saying that they won't accept any evidence for anthropogenic global warming unless that evidence fits the standards of science, okay, which they say is reproducibility. Well, that cuts out pretty well all the evidence for global warming because you can't reproduce it. But of course, that isn't the standard of science. The standards of science are something different. And the sort of thing that I think people like me have to do is explain how science works so that people don't have such an elevated opinion of it that when they see things go a little bit wrong, like in the ClimateGate example, when all those emails came out of the University of East Anglia and they saw scientists slagging people off, they ought to realise that's just normal science. That's how science goes. There's nothing scandalous about that at all. So we have to explain what science is. Anyway, so wave 3, we said, no, somehow or other we've got to reconstruct science as something special and different if we are to preserve society as we value it. But we've got to make sure this is not incompatible with wave 2, because wave 2 found a lot of very interesting things out about science, and we've got to preserve all that. We mustn't just go back to wave 1. So what's wave 2 going to look like? Well, there's Mount Science. There it is eroding away. What we've got to do is build some new foothills, and the way it's going to be done is by starting to think about expertise instead of truth. Truth is far too difficult to understand. Truth is far too difficult to hang on to. It takes scientists usually, when there's highly disputed things, half a century to decide what the truth is. Max Planck said, science advances funeral by funeral. Or he's said to have said that anyway. So get away from truth. It's too problematic. But you can still argue for the preeminence of science by arguing from expertise. So that's where we went. And there's got to be expertise. Look, if there isn't expertise, why did you fly me all the way over here from the UK? You could have just got somebody in from walking by the corridor. They would have done this just as well, unless I'm some kind of expert. So, it doesn't make sense to start thinking that you can have a society without a notion of expertise. It would really change a lot, and it would be a dystopia. So whose views about the natural world should be preeminent? You want to know something about the natural world? Who should you ask? Should you ask your mother? Should you ask Jenny McCarthy, who is the Playboy model who said MMR vaccine isn't safe because my child has become autistic as a consequence of being injected with it? Should you ask journalists seeking balance in their stories? No. I think we argue it just makes sense. Ask the people who dedicate their lives to the study of the natural world, and those are the scientists. Give their view a bit more weight. So the whole thesis is as simple as that. And the argument is that's got to be the way to bet. Ask people who know what they're talking about. Of course they're going to get it wrong a lot of the time. We know. Just look at the mistakes experts make. Look at economists. Look at all sorts of other people. They're always wrong. They're always arguing with each other. So that means at least half of them must be wrong. Okay. But nevertheless, if you're going to have an argument, those are the people whose views should be most important in the argument. The people who spend their lives studying this stuff. Well, this grew into a whole study of expertise, which has been quite successful. That is what we call the periodic table of expertises. We called it the periodic table of expertises to irritate as many people as possible. And there, along the bottom line, is interactional expertise. Let's just have a look at that row, because we haven't got a lot of time. So I'll just talk about this row, the specialist expertise row. Talk about that for the moment. There's 5 expertises, a group of 3 on the left and a group of 2 on the right. The group of 3 on the left are expertises, or so-called expertises. They're really knowledges that you can get pure, so long as you can base them only on that line at the top, which is ubiquitous expertise. Ubiquitous expertise is what you have to live in society, you know. Without ubiquitous expertise, I might have turned up here in my pajamas, but my ubiquitous expertise told me, no, I should put on shoes and trousers and a shirt. Okay, that's something I know. It tells me how close to walk to people on the pavement, according to whether it's crowded or not. It tells me how to read books, how to use a library, how to speak English. Here I am producing well-formed English sentences, I hope, and this is me demonstrating my use of ubiquitous expertise. Tacit knowledge in the case of producing sentences, I don't know how to produce them, but I can produce them somehow or other. But with just that ubiquitous expertise, you can have beer mat knowledge. Left-hand category, beer mat knowledge is, I took the name from a beer mat, a coaster, which I found in a pub once for Babysham it was, and it had a 5-line explanation for how a hologram works. So I read that for 5 lines, and now I know how a hologram works. But beer mat knowledge is only good for Trivial Pursuit and things like that. Popular understanding you can get from reading popular science books. Don't trust it, it's not good. And primary source knowledge, which I'm going to explain in a bit, also isn't good. You can get, if you really work hard and go back to the original scientific journals and study them, and you can get the drift of them actually, even if they're full of mathematics and you don't know any mathematics, you can still get the drift of what's being argued quite often. But don't trust it. The expertise you have, the two things to the right are the two that Paul has already mentioned. That you can only get those if you have specialist tacit knowledge, and you can only get specialist tacit knowledge by mixing your socially with the community who already has the specialist tacit knowledge. And then you can have contributory expertise, the rightmost category, which is what we normally think of as expertise. It's the ability to do things. And then you can have interactional expertise. And this is the new category. And this has been quite successful, this category, actually, in academia. And I think it's a very, very important category. And the more we think about it, the more important it seems to us. And it's the ability to understand something that you get through long-term immersion in the discourse of the people who have the full-blown expertise, the full-blown contributory expertise. So that little test that Paul mentioned, that I passed, well, I'll come on and mention it again in a minute. Now we're going to take a sort of parenthetical excursion and talk some more about interactional expertise. There's interactional expertise. It's a practical accomplishment, interactional expertise, because you have to learn to speak the language. And it's like learning to speak a native language. You learn to speak a technical language. It's not walking the walk, that's contributory expertise, but it's much more than talking the talk, as people like to dismissively say. So we call it walking the talk, okay? Because you can do something with it. For example, let me just go back. Let's take this field of gravitational wave physics that I'm immersed in. It's now about 1,000-strong, billion-dollar scientific enterprise. I spent from the mid-90s to the mid-2000s really deeply immersed in that field. That's where Paul gets the decade from. I was really deeply immersed in it for about that. I spent more time with gravitational wave physicists than with anybody else. I'd sit around in the coffee breaks talking physics with the physicists, and they were very happy to talk physics with me, and on a very rare occasion I'd make a good point. Rarely, but occasionally. But then it occurred to me, you know, after I'd got this, I thought, oh, I'm a special kind of person, a sociologist who immerses themselves in the native language and gets it. And then I realised, but wait a minute, what about people who are managing this project? They don't actually do the calculations. They don't actually spend their time on the bench with a soldering iron, but they generate enough technical understanding so that their technical decisions are respected by the scientists who are actually doing the calculations and building the apparatus. And they work through interactional expertise as well. So it's a pretty deep level of expertise, okay? And you can do things with it. You can make contributions, oddly enough, you can make contributions to the scientific field like the technical managers do by just having interactional expertise. And I eventually wrote a paper together with Gary Sanders, who was the project manager of the Laser Interferometer Gravitational Observatory, where you know, we sit down together and work out what interactional expertise is, and he agrees with me that how he does it is via interactional expertise. And I think it also explains the division of labour. Certainly in a technical field like that, you have people who have the ability to do certain practical things, other people have the ability to do certain other practical things. They can't do each other's practical things, or you wouldn't have a division of labour. You know, you have specialists. But the way they coordinate their actions is by sharing a common language, by having interactional expertise. So you can't be a contributory expert unless you also have interactional expertise, and we think it gets more and more important. So then we invented some ways of testing this. We did the Turing test, if people have heard of that, was based on the so-called imitation game. Alan Turing talked about having a hidden man pretending to be a woman and a hidden woman answering naturally, and a judge trying to work out who was who by passing them questions. We started running those kinds of tests. Here's one we ran. We had blind people pretending to be sighted, and they were asked questions by a sighted person, and those questions were answered by the blind person and by another sighted person. And the sighted judge had to decide who was who. And we did a comparison experiment in which we had sighted people pretending to be blind, and the questions were asked by a blind person and also answered by another blind person, and the judge had to identify who was who. And now I'm going to ask you a question. Who did best? The blind people pretending to be sighted, or the sighted people pretending to be blind?
I'd say the blind people pretending to be sighted.
Who thinks blind people pretend to be sighted did best? Who thinks sighted people pretend to be blind did best? Okay. Somebody who thinks that sighted people pretending to be blind, blind people pretending to be sighted best, hands up again. Why?
Intuition.
Anybody else? That's
More
crap.
information.
What?
The blind person has to live in a sighted world.
Yes. Okay. Because the blind people are immersed in the language of the sighted people all their lives, and so they pick up the interactional expertise of being sighted, okay? Whereas the sighted people don't pick up the interactional expertise of being blind, because you don't mix with sighted people. You, sir, can redeem yourself now.
That's what I meant.
Okay? By telling me what's the next experiment I should do in order to find out if what I just said was true. Nah, that's too tough. Okay, so what we do is go and get some sighted people who run blind dogs for the guide dogs for the blind or something, who are immersed in the language of the blind, and see if they do better. We never actually did it, but it's waiting there for somebody else to do. Okay. There's some dialogues, but we haven't got time to go through it. In fact, it was 86% roughly of the blind people managed to pass as sighted, and only about 13% of the sighted people managed to pass as blind. So it's a pretty good result. Then there's me, who decided to pretend to be a gravitational wave physicist to try and put my money where my mouth was. Let's see if I could pull it off. And in fact, so it was me who organised it, and we got a gravitational wave physicist to ask me questions and another gravitational wave physicist questions, and we both gave our answers. He actually decided to ask 7 questions. Very simple experiment. It was actually run over by email with a postman handling the questions, so nobody knew who was who. He asked 7 questions. We had to reply, write back our questions fairly quickly in real time. And I will just concentrate on question 5 because that's the most interesting one. So there's the question on the top and the 2 answers, one answer from A and one answer from B, and you have to decide Which one is the real gravitational wave physicist and which one is me? So give you a couple of minutes to decide. Then I'm going to take a vote. Okay, who thinks I am A? One. Who thinks I am B? No, a few more. Why? Why do you think I am B? Somebody want to tell me why you think I am B?
Answer isn't as technical.
Isn't it?
It doesn't deal with the sort of instrumentation.
Okay. Well, in fact, I am B, and in fact, the physicist thought I was the physicist, because actually my answer is technical, and is better than that of the physicist. I could explain why. The physicist who answered question A is giving an answer that can be found already published in a journal paper, which I didn't know. Okay, so I had to make up an answer which was B, which was correct, and it's better because answer A, it's actually impossible to do what he says you should do in answer A. You know, it's possible in theory, but it's not possible in practice. Whereas mine is a correct answer for the instruments that actually exist. So they decided I was the physicist. Well, what it was is the dialogue, 7 questions and 7 pairs of answers, was sent to a panel of 9 physicists, and they were asked which one's Harry Collins and which one is the genuine physicist. And 7 said they couldn't tell, and 2 said I was the genuine physicist. But I should add, we banned all mathematical questions. And if you want to know the truth about the experiment that very few people know, we also had to edit the answers because stylistically the answers were so different that it was obvious who was who. So we edited them stylistically, but got all the parties to agree that this stylistic editing didn't make any change to the scientific content. So that was me passing, and Nature wrote it up and said, sociologist fools physics judges. And for those of you who know what this means, they got Alan Sokal to comment on it, okay? Which was rather unfortunate because it intimated that I had hoaxed the physicists, whereas I hadn't hoaxed the physicists at all. I'd actually demonstrated expertise, which Alan Sokal didn't. It was the whole point of his hoax that he had no expertise. The whole point of my experiment is that I did have expertise, but never mind. Nature likes a story. And we did more experiments of this sort. We did them on the colourblind and people with perfect pitch. We did them on the blind. There we are. We did them on sexuality. We did them on religion. We did some on gender. And we got a very, very large grant from the European Research Council to go around in different regions of Europe using the imitation game on a very large scale to test whether one kind of group could pretend to be another, using that as a proxy for the degree of integration of the minority groups into society. That grant is just coming to an end. So that's that. We also tried it in different ways. There's groups of our students playing in groups instead of as individuals. Men pretending to be women, women pretending to be men. And there's also, there's an app which you can download if you have an Android device, so that you can play the game in the pub and have a good time with it. So that's the end of the sort of interlude about interactional expertise. Now, I said I'd say that why primary source knowledge is a dangerous thing. That little red star up there, is a crucial dividing line. The trouble with primary source knowledge, even knowledge that you get from the journals, is you cannot know what a journal article means without knowing the extent to which people within the expert community take it seriously. Okay, so you can get, this is the trouble with what Tabo and Becky were saying. If you look at the internet, you'll find some pretty convincing stuff. But if people aren't taking it seriously, it isn't worth anything, not according to the scientific community. So to give an example, remember I said Joe Weber was the person who first detected gravitational, or said he first detected gravitational waves. By 1975, Joe Weber had lost his credibility. In 1996, Joe Weber published a perfectly respectable looking article saying he had found a correlation between his old gravitational waves and another cosmic phenomenon called gravity wave bursts. 3.6 standard deviation correlation between them, a potentially Nobel Prize winning finding. I went around the gravitational wave community and said, hey guys, what do you make of this? Joe Weber's latest paper. And it turns out I was the only person to have read it among this community of 1,000 or so. Because Joe Weber had lost his credibility and nobody was going to take any notice of anything he said. That's one of the ways that science works. And the same was true of the Tabo and Becky case. The people who are arguing for the dangerousness and non-efficacy of antiretroviral drugs had lost their credibility some years before. That's how scientific disputes end. People get past an idea gets past its sell-by date. Sell-by date's right for Canada, is it? Is that what you call the date you have on food? Best before date. Yeah, people get past their best before date. And then nobody takes any notice of them anymore. You get a run for your money, you can say an outrageous thing, and you will get a run for your money if you're provocative enough and your work's good enough. People will take some time and test it and argue about it, but after a period, it just goes away. And then that's no longer a proper part of the scientific community. It's a social process, okay? So that's why you've got to be very, very careful with the internet. Oops, we jumped. But there are things that the general public can do, and whistleblowing is one of them. In this diagram, it's called local discrimination. Whistleblowing, if you know something about the scientists in some local, and you know, for instance, they're being paid or bribed or not doing things properly, you can blow the whistle on it. That's a very important role for the public in affecting scientific outcomes. We have, now how much time have I got? Because I've got a feeling I've used it all up. No good, no problem? All right. We have now what we call the sandwich model of the relationship bit. This is where we're coming on to the democracy bit. The sandwich model of the relationship between science and society. That's the two slices of bread, top and bottom. The ugly bit in the middle is the science and technology. And then there's two little oval shapes, which are the butter or the mayonnaise, depending on how you prefer it. And the top slice of bread is the citizens, the political system's right to decide what sort of science should be done. You know, the citizens presumably want plenty of medical science done. They certainly seem to like astronomy and astrophysics these days. I don't know why, but there's huge support for it. You probably want better economics, okay? And you decide that that kind of science should be done, and then you get to the oval bit, which are certain sort of institutions which feed these political decisions somehow or other into the scientific community. That's the research councils and so on. They translate the political will into the scientific community. And then you've got the scientific community. And in the well, let's see, I don't quite know how to explain this. Then in the scientific community, there's some other institutions. Well, this is, no, I'm getting ahead of myself. That's our sandwich model. Let's just go there. That's the only thing. There are two things that citizens contribute to what goes on in the middle, the actual science and technology. One of them is local discrimination or whistleblowing. They can definitely contribute that, and it's extremely valuable. And the other thing is experience-based expertise. I mean, the most well-known case study on this was done by a man called Brian Wynne, who studied what happened after the Chernobyl nuclear power station exploded. Lots of radioactive dust landed on the Cumbrian Fells in north of the UK. The sheep became radioactive, and then there was a big debate about what should happen to the sheep. The Ministry of Agriculture and Fisheries Science went up there and told the farmers what to do, and the farmers told the scientists, no, you don't know what you're talking about because you don't understand sheep. And I think it's generally agreed that the farmer's view should have been taken into account. The difficulty with this study is that Brian Wynne and his colleagues then started talking about lay expertise. They said lay people had the ability to contribute to the scientific debate, but the problem was that the sheep farmers were not lay people, they're expert sheep farmers. So you couldn't have gone up and told people how to handle the sheep on the Cumbrian fells. They were a very small elite group who had something to say. And it's important that those small elite groups' voices are heard in scientific disputes. It's very difficult to work out who's got the right and who hasn't, but I'll come on to that in a bit. But those are the other sort, that's the other kind of thing that citizens can contribute, experience-based expertise. So the way to bet is to take most notice of those who have dedicated their lives to the study of what is in question. There are competing groups, and that includes the experience-based experts. But also, if I just say that, it includes groups like astrologers. I mean, astrologers have dedicated their lives to studying the impact of, you know, how people's lives work out. Why don't we take any notice of them? And this is where the argument gets really difficult. You know, you can't argue it from expertise because astrologers are experts. They're experts at astrology. They're better at astrology than we are. And it requires a lot of time to become an expert in astrology and run a newspaper column and so on. So this is a tough one. And it is, I think, a very tough one. And you're not going to think too much of my answer to it, I don't think, but this is the best answer I can give. And the answer is called elective modernism. That's the theory. And the other answer is just setting up another committee. Okay? And the committee is called the Owls. And I'll come back to the committee, but I'll talk about elective modernism first. What elective modernism, you know, let's just say, we go back to wave one, where the argument for science was that there is a logic to it. Popper and so on and so forth. Wave two tried to was descriptive about science, and wave two said science is just ordinary life, a continuation of politics by other means, nothing special about science after all. Elective modernism is prescriptive about science. It says science is not a logic or a practice, it's a culture, a form of life. And this is where it gets dodgy, the form of life, the goodness of which is self-evident. Okay? And under elective modernism, science is valued for its values, and here echoes of Robert Merton can be heard. Science is echoed for its values, not for its success. It, at its best, represents the values we stand for. So, as well as being the way to bet, science is treated under elective modernism as a beacon of values, irrespective of the outcome of any bets. So this kind of argument for science has to be shown to work even in those cases where the science clearly doesn't work as a generator of truth. So if this argument is any good, it has to work even for economists. Okay. Who are the most reliable producers of untruth that we have. So that's what a provocative argument it is. Okay. So let's just see how it works again. This is saying the same thing again in a different form. There's wave one, we had the logic of science. There's wave two, science is a form of life or a culture. And what we do is take elements from wave one, pass them through wave two, and look at them again as values, as elements of a form of life. And I'll give you an example of how this works with Popper's falsificationism. The thing about falsificationism is we know, any philosopher knows how to show that falsificationism doesn't work. Imre Lakatos showed that falsificationism doesn't work. Imre Lakatos showed that shall we say, it is not true that when you see a single black swan, this proves that not all swans are white. It doesn't prove it because maybe that swan was covered in paint, or maybe that swan was covered in soot, or maybe there's something wrong with your eyes. And it turns out that there's so many maybes that it's just as hard to falsify something as it is to corroborate something. So Popper's falsification doesn't work. And yet, on the other hand, Popper's falsificationism does work. All you people who've used Lakatosh's arguments against Popper's falsificationism have almost certainly also invoked Popper's falsificationism as an argument in debate. You've said to people, well, that's all very well you saying that, but how would you falsify it? So we know, actually, Popper's falsificationism is right, even though we can prove logically that it's not right. How does this work? It's a value. Scientists, in their work, try to develop hypotheses which can be falsified. It's better if it can be falsified. Okay? It doesn't matter if your hypothesis can't be falsified, it's just not quite such a good hypothesis. Okay? It's a value. It's like trying not to bump into people on the pavement. That's what you try to do. You try to falsify, you also try to corroborate, obviously. All the bits and pieces of the logic of scientific discovery which philosophers invented are preserved under wave 3, but they're transmuted. They're transmuted by wave 2, which is a kind of philosopher's stone, into values rather than bits of logic. And you don't have to worry about the fact that they're not logically immaculate any longer. You just use them as general guidelines for how to live a scientific life. And there's a list of them on the right. Time's getting on, so I won't go through them, but lots and lots of them. How does this differ from Robert Merton? Merton thought that the values of science, that democracy was good because it precipitated good science. We just say, no, those values are just good in themselves. And the reason to value science is because scientists, good scientists, on the whole stick with those values. And we need science as an institution to act as a beacon of values in our society. Because in our society, institutions which can act as beacons of value are disappearing very, very fast before your eyes. When I was a kid, the banks were a beacon of values. Yeah? You knew your money was safe with the banks. Now you know you better check your account every month to see how much they've gouged out of it because you went a penny overdrawn. And you know what's happened with the banking institutions. Now you can't trust them at all any longer. So we need institutions which can act as a beacon of values, and science, gravitational wave physics, for example, which I know very well, could act as a beacon of values. Not all science can. Lots of areas of science can't. But we've got to drag them back and get them acting as beacons of values again. This must be true. Science must have special values. If you don't think science has special values, then you better stop complaining about the scientists who've been bought by the tobacco lobby or the oil lobby to produce results that justify their political interests. If you don't think science has special values, then you've got no right to complain about scientists finding things for pay. They're just doing a job for which they're being paid. But if you think it's terrible that people produce results that say tobacco is safe because they're paid for it, then you already know that science is a special kind of institution, which it is. These two circles represent science on the left and democracy on the right. We say there is a big overlap between scientific values and democratic values. Scientists produce policies, think they produce when they can produce policies, but policies have to be judged in the political sphere. Scientists can only propose policies. The political sphere has to produce policies. That's the sandwich model. So the bottom slice of bread is the political sphere, the public, who decide what to do with what the scientists have produced. Thabo Mbeki, the thing that Thabo Mbeki did wrong was to say to his upper chamber of his house, you could go and read the internet and find out there's a scientific dispute about this, because there wasn't a scientific dispute about it. Well, if Thabo and Mbeki had said, there isn't a scientific dispute, but in South Africa we are not going to distribute antiretroviral drugs to pregnant mothers because they're too expensive, because we don't want to come under the thrall of Western big pharma, and because we don't want to project an image of South Africa as a disease-ridden country, he would have been politically perfectly entitled to say that. And people could have voted him in or out of office next time the voting came around, the election came around. But by saying that it was scientifically demonstrated that antiretroviral drugs were unsafe, he was actually disempowering the electorate, because you can't vote for whether something's safe or not. You can only vote for whether you want to use it or not. Okay? So that's why it's vital that people don't distort the science, present the science truthfully and honestly, and then but that doesn't predetermine your political policies. You've still got a choice over political policies. That's why this isn't an argument for technocracy. Technocracy tries to convert political judgments into a scientific calculation. This doesn't. It says political judgments are political judgments. The bottom layer of mayonnaise, or butter, is what we call the owls, and we say we should set up a new kind of committee, fulfilling the same kind of role as government scientific advisors. They're called the owls because it would be made up of scientists and social scientists. The scientists are a special group of scientists. They're those who can turn their heads around 180 degrees like an owl. Okay? And there are scientists like that. Peter Medawar, Thomas Kuhn, who was a scientist, Gerald Holton, various people who are capable not only of doing good science, but also of doing very, very good social science of science. Very good. And the social scientists have to be people who can not only do the social science of science, but also understand the science. They can turn their heads around 180 degrees as well. They start off pointing in different directions, but they can share each other's perspectives. So that's the extra committee we set up. If you take this, we can now have a new role for sociologists as a member of the owls. Analyse the nature of expertise and work out who is an expert. Work out which non-scientist, experience-based experts should be included within the group that makes scientific decisions. Very difficult problem, but the social scientists will make it work better than if they're not there. Understand the nature and timing of scientific controversies, which are real and which have passed their best by date and are therefore counterfeit scientific controversies. Indicate the boundaries of scientific expertise in respect of specific controversies. Analyse the propriety of science. Where are the norms not being followed, as they're not being followed, say, by the scientists who take money from the tobacco lobby. And then grade the degree of consensus in respect of a scientific conclusion. Economics, a grade D consensus. Gravitational wave physics, a grade A consensus. And this prevents politicians doing things like saying, we have to run this economic policy because the economists tell us this is the only way to go. Economists don't tell you anything of the sort, okay? So it stops politicians using science in that way, and it also stops politicians using science in the Thabo and Mbeki way. So what we've done is discovered what science studies is for after all these years, I believe. The next slide shows you some books to read. So if you'll forgive me, I'll just advertise. If you want to know about expertise, there's our 2007 book called Rethinking Expertise. Very nice issue of Studies in History and Philosophy of Science, which contains a lot of articles about this stuff. There's a book about tacit and explicit knowledge, published in 2010. There's the book, Are We All Scientific Experts Now?, which Paul mentioned. And there's a book we're writing, which is called Why Democracy Needs Science. And you can imagine what's going to be in that. Thank you very much.